Hello, my name is Lindy Humphrey, and this is my lab report number 5 for Physics 2211, and I chose to do the falling Slinky for this Choose Your Own Adventure kind of lab report. To introduce this lab, the purpose is to analyze and predict the motion of a falling Slinky dropped from rest, and we will also have to evaluate and see the influence of gravity and drag on its final motion. We will use Tracker to track the Slinky's position to be able to analyze it, and GlowScript to code a computational model to predict what the position will be. To give an overview of the results as well, we will see that the bottom of the Slinky will remain relatively stationary. Some key concepts or fundamental principles we must include are Newton's second law, also known as the momentum principle, represented by the formula F net equals delta P over delta T, or V final equals V initial plus F net over M times delta T. The gravitational force, which is represented by negative mg, tension force, represented by the Slinky, or equal to the Slinky, and drag force, also known as air resistance, along with spring force, represented by K times L minus L naught times L hat. It is important to note that the gravitational force works in the negative y direction. These forces added up, the gravitational force, the drag force, and the tension force equal to the Slinky, all represent F net, also under Newton's second law of motion. And some initial conditions to include is that the Slinky's initial mass is around 0.21 kilograms. And the initial velocity is a zero vector here, since it is not initially moving. When you put the video into Tracker, we first had to set the origin to the bottom of the Slinky, and as the video plays and the Slinky fell, we had to make sure that the center of mass was pinpointed on the Slinky as it fell, in the center of its mass. And it stays in the same position as it goes down, or it is basically motionless, until the top of the Slinky reaches the bottom and the rest of it starts to fall towards the ground. That is why the graph we will see later from Tracker and from GlowScript as well, to compare, will show that the line right along the x-axis as it begins to fall, but then it turns into a sloping downward graph. Here is also an overview of my GlowScript code and everything I needed to fill in to create the computational model for the Slinky's falling motion. We had to fill in the initial conditions, things like the ball's mass, code for how the Slinky moves and falls throughout the duration of the video, and eventually to find how we can predict how it would fall. And given the data from Tracker that evaluated the position of the Slinky as it moved from our video, represented in this first graph on top, and the data from GlowScript that we coded for the predicted position, shown in the graph below it, we are able to combine them and compare the data for how the predictive model compares to the actual movement of the Slinky. And we can see that while the two graphs are pretty similar, there are some fluctuations that may have been caused by different things in the real world versus an experimental model or a computational model. Things like wind not being accounted for in the predicted model that could have influenced the actual motion since it is just outside, and things in the real world impacting the motion, and things like human error as well, such as the Tracker placement points being slightly off as we try to pinpoint the center of mass and pinpoint the direction of the Slinky's movement going down. However, they both start along the x-axis as they fall and show that sloping downward graph. Finally, the question that we have to answer for this lab is, does the bottom of our model Slinky stay stationary just like in this video that we had analyzed? And the bottom of the Slinky does remain mostly stationary until the top of it reaches it. That is when it begins to fall altogether. This is because the forces in the y direction cancel out, and although the gravitational force acts downward, the Slinky is just a big spring that counteracts the force with a tension force of equal and opposite magnitude. And that is all for this lab report. Thank you for watching this final lab.